Mathematica 10.0. I've been using Mathematica since it was like version 3.2, okay, like a long time ago. This is all pretty much C++ code, and so this is all the code that I wrote to make these animations happen. So anyone who's like interested in CS or like computer programming,
how'd you learn that?
just over time, by necessity.
Reading books and just keep working on it?
More trial and error than anything else.
Pretty cool.
So in my calculus classes, I share this with anyone who's interested in learning the code. It's just syntax. It's not, there's a lot of built-in functions, so I'm not like really doing a lot of hardcore like if loops and do loops. I'm just calling up functions, but you can do some really cool stuff with this. In fact, I have my Cal 3 here. This is Cal 3. These are things I've done in Cal 3. These are three-dimensional animations.
How many axes is that? 5 axes?
Which in Cal 3 it's very useful because most people have difficulty in Cal 3, not because it's harder, it's because it's hard to visualize the space that you're in. So with 3D visualization, it becomes a lot easier.
Is that what we're doing right now?
Like this,
Yeah, we're
right
doing
here.
coffee right now.
I don't want to see this.
So we're, like in Cal 3, we try and find the volume of that thing, which is basically a bunch of different objects that are cutting through. You've got like these different planes and different cylinders, and we're trying to find the volume of that thing. So, but it's hard to visualize that without some computer animation to do it. All right, I think I'm done talking about this. All right, let's try another law of cosines problem. Okay, so World Series just happened, right? We have, in a traditional baseball, they call them baseball diamonds, right? You've got home plate, you got first base, second base, third base, right? And the distance between the bases is 90 feet, all the way around. Okay? 90 feet. And even though they call it a diamond, it is a square. All right, this is a square. So this is 90 degrees, 90 degrees, 90 degrees, 90 degrees. All right, so in this particular baseball field, let's say that somebody hits a ball from home. They hit a ball out here directly over second base, and this guy catches it out here. And let's say that he is 352 feet out there when he doesn't catch it. If he caught it, it would be an out, right? Let's say that it's a blooper, it hits the ground and rolls to him, right? And he's going to try and make a throw to third base. This is third base. My question is, what's the distance that he has to throw that ball? Everyone understand?
Yep.
Okay, I'm going to give you all some time to work on that one. So the question is, the throw from this center fielder to here, what is that distance? I'm not telling you whether or not you need law of sines or cosines or anything else. Just see what you can do with that. Yeah, y'all can talk to each other.
We're just finding that length, right?
All I want is this length right here. That's it. This is not like a super complicated problem like the previous one with the calculus part thing. It's not that. It's just, this is pretty much a problem right out of the back of your book. So, or back of the section. Start drawing triangles. That's my advice.
It's 45 because it's a straight line.
Yes, you can assume that that would be 45. Yes. Uh-huh.
Otherwise it'd be
Yeah, I kind of had to give that to you, that it was right down the center, or else this would be a little more complicated. Yeah.
just Pythagoras, yeah.
Where's that?
Because you have the 90 feet and then the distance is 352, so just do that.
But is that a right triangle? You can only use Pythagorean if you have a right triangle.
Oh, yeah, you're right.
If you're having any trouble, try and draw the triangle that you're going to be working with here, okay? See if you can get the triangle that you're going to work with, and then which sides do you know, which sides do you not know? There you go. Yeah, so you're using, you got it turned, let me see. That's basically that, right? Like this, that. Yeah, you got everything. That's everything you need right there. You got, yep. I'm not gonna give you anything else. You've got it all there.
So you get 90, but you have to get the,
So you have 35
What's up? What is it? Oh, not right now. Not here. I mean, let me walk around a little more and see where everyone is.
yeah, I mean, but not talking about this size.
Now, do you know that this one is that 45? Yeah. Do you know that that's 45? Look. Wait a minute. Which triangle are you drawing? Hold on. Maybe I looked at. No, I think no. You drew this one, right? You went here, 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 right? That's 45. I agree. This is not 45, right? I don't know what the answer is yet, but let me see. You used 352 and B and then 90, right? And then the angle's 45. It should, yeah, that should be it. Let's see what other people get. Does the answer make sense? I mean, think about. I mean, right? It shouldn't be bigger than 352, right? And it should probably be more than 150 or so, right? So your answer seems reasonable. Yeah. What did you get? 295.2 something? 295.2 something? Okay, that seems right.
Yeah. I mean, it's a straight line.
Feet, yes.
45, so you already have. 45. Whatever you have, the cosine of 45, that measures that. You'll know the exact.
This is 45. This is 90.
No, that wouldn't.
I'm going to put another problem up here for you to start thinking about if you get past that one.
So that means you have three angles. And if you have an angle here, you can have it opposite this one. Say this is 180 degrees. So we know that this is 90 degrees, 45 and 35. 45 degrees, right? So you actually know right here, you know this to be 45, 45 subtracted. Yeah, this is 135, so 135 degrees. So we know that, we know the length of this, so we know 135, we know the side. We need to figure out this distance right here, because then we can subtract it from this one, and then we'll have a value.
Okay. Yeah, yours is a lot easier, and I'm gonna draw mine larger.
So 350, so a total of 352. So we have to find an angle of, we have to find a length of this. So we have, like, the one. Okay, so it would be.
I'm just going to put that up there for now, and then I'll talk about it in a second. Who's still working on the baseball field?
We are.
You getting close?
I think so. I kind of want to push this.
Can I see what you have? What triangle you're working with?
We deduced, we cut that in half, 45.
Mm-hmm.
And then from there, I knew that would be 90. So I drew the line across there. We deduced that was 45.
Okay.
Over a 180-degree plane, that's 135. My deduction is now that I have to discover this side and subtract it from that. I'll have a length in here, and then I'll have side angle side.
That's.
Too much work.
I think that's too much work. That.
So, so you have a...
Just use the big triangle.
Okay, so have a value here, a value here. Okay, I see what you're saying.
Yes, and then you have one angle inside.
So
That's
now-
all you need.
So now I have a 90 side, I have a mystery side.
Yep,
I know that this is 45.
yep. And that's the 352.
This side.
This is 352, right?
Oh, so now, yeah, now I have side angle side.
Yep.
Side angle.
So we can.
Okay. Anyone else?
To find the B side, I'm using this equation.
Mm-hmm.
And then once we get that, I plug into the C to get the C.
You don't need the angle. You have the angle, don't
Then we
you?
could use the law of sign.
No, this is right, but your cosine B should, B is 45.
It's 45.
So just put 45 right there, cosine of 45.
Yeah.
And then just compute it.
I was like, but after that,
You're done, because you're trying to find that side B, right? That's all you need is B? You called this B, right? So this right here, you just take the square root of that answer and you're there. 295 something? No? 262? Let me see.
I got 268.
You did 325, not 352. You flipped your numbers. It's okay, don't redo it.
Okay.
Just leave it, just on your picture, change that to 325. That way it matches up with your work. How about here, guys?
Not sure if that's right, but this is what I got.
Okay, so where's your triangle that you...
The middle part.
And you tried to figure out what that was?
Yeah. Or since this is like 45,
Yeah.
I took off 45 from the 32 and I
Yeah.
got 307.
See, that's working too hard, and you're not coming up with the right thing. Do you have a triangle that you're working off of? Yeah. 45, yeah. You should try and work off this bigger triangle. That one right there. Because you know this angle is 45 degrees. Because it's right down the middle, it's half of 90, right? So your triangle looks like this. This is 45 degrees. This side is 90. And then this side is 352, or 325 if you want to use 325. 352 here, 90 here, 45 here. Does that make sense? And then you should be able to get that side using law of cosines. Okay? All right, let's take a look at this other problem. So this problem is a very bad picture, but this is similar to like a piston engine. All right, so I normally wouldn't have drawn it this way. You have a piston. You have, what is this arm that comes down?
The connecting rod.
Connecting rod to your piston.
Yep.
Okay, and that goes to
The crankshaft.
the crankshaft. So crankshaft here, this turns, right? So you have basically an explosion inside of a chamber here. Gas and air mixture, spark, ignition, explosion, pressure, pushes your piston down. That pushes this rod this way. That rod is attached to this circle. That point must move, but it has to move along the circle, so it starts turning. All right, so this is your internal combustion engine pretty much in a horrible diagram here. All right, you're turning linear motion into circular motion. That's the way these engines work. So this turns this, crankshaft turns, goes to your transmission, transmission goes to your
There's a whole bunch of work.
differential, and then that goes to your wheels, and your wheels turn, right? That's the way an engine works.
Sun gears and planetaries.
Yeah, it's a little more complicated than the way I'm describing it, but good enough, right? Okay, so in this problem, what I'd like for us to do is find an equation for x in terms of theta. So I want you to give me an equation that says x equals something, and in this something there needs to be theta. X can't be here, just theta. Now it can have other things in there, but that would mean that x is a function of theta. So if somebody gives me the angle, you will be able to tell me how far the center of the crankshaft is from that point. See, this piston is moving. And so at different angles, that position is going to be different, isn't it? So if the crank is if it's all the way back here, right, then this rod is 8 inches long, then that's going to be way back here, isn't it? And that distance is going to be smaller. So do you think we can do that? Let's see. Maybe we can. I don't like my picture.
Figure what location of crankshaft.
Yep. Okay. What is it? This was 8, right? This was 3. This was our piston. And then we had our crankshaft here. We had theta here. And what am I missing? Oh, x was the distance from here to here. Okay, so let's try and come up with some relationships we have here. Anything? Anything? You want me to do anything here? Do you see a triangle at all in here? Okay. Do you see this triangle? Do you see that triangle? Okay. If you see that triangle, then there's got to be something that relates these all together, right? How about law of cosines? Let's try law of cosines. Law of cosines would tell me that maybe we should label these. Let's label this A. Let's label this B. Let's label this C. This would be angle A, right? That's what I would have there. So let's do the equation for A squared. And the reason I'm using the equation for A squared is because I have information about capital A. So if you use this A squared equals B squared plus C squared minus 2BC cosine of capital A, then what will that equation turn into? A squared, which is 64, equals B squared. What's B squared? 9, right? Plus C squared, but what's C? X, so I'm going to put X squared minus 2 times B, which is 3, times C, which is X, times cosine of theta. Y'all okay with that? Wow. Let me clean it up a little bit. I can subtract the 9. If I subtract 9 from that, I get what? 55 equals, this is actually going to turn out to be really cool now that I see this. All right. That's what we have, right? The instructions were to solve for what? Solve for x, right? Find x in terms of theta. Zach, I think we need your opinion on this one. This is a good one, Zach. Now, I don't know about your opinion, but think about this. I don't think most students have never seen something like this before. I want this to be turned into an equation where I have x equals something, and it needs to have theta in it, and it can't have x in it. Why can't it have x in it? Because x would then be in terms of itself, right? It would be like, in order to know x, I need to know x.
Yep.
And that's circular, so you can't. I want to know if someone gives me theta, can you give me x? So how in the world do you solve this? Okay, you could factor an x out here, right? And that's usually something we would do if this thing was equal to 0. Let me go back and explain. If I said x squared minus 9x equals 0, then you would say, factor an x out, you would go x minus 9, then you'd say equals 0, and then you set them both equal to 0 and you're done. However, if I have x squared minus 9x equals 3, we could factor an x out, but we do not set each one of these to 3. That would be incorrect. This only works when you have 0 on this side. So even though we could factor an x out, I'm not quite sure where we would go with that, because we still don't have 0 over here.
Take the root of both sides?
We could, that's a legal move. We could take the root of both sides, but if we do the root here,
It's going to get up with
you can't do the root of each of these separately. So it's going to be probably worse than we started with.
So we can't just solve the equation?
What do you mean?
Can we like solve
No, you gotta get, have theta and x in separate.
Solve for x, you mean? Or I'm not sure. Yes.
Instead of doing a squared, why can't we just use x squared? X squared equals, and then plug in everything else, so it would be 3 squared plus 8 squared, the square root of 3 squared plus 8 squared minus 2 times 3 times 8 cosine of theta.
Okay, so you're saying use the law of cosines, but do the x squared one instead?
Yeah.
So what would we have gotten? Did you have?
Because I did it.
Let me draw it again real quick. Let me draw it again real quick like this. 3, 8, theta here, and then x here. That's what we had, right? And I called this side A, right? I called this side, help me out here.
You called x c.
Yeah, XC.
X was C?
Yeah.
Oh, X was C,
3 is B and 8 is A.
3 is B, and 8 was A. That's the way I labeled it, and I call that capital A. You're suggesting that
What I did was x equals b, little b.
X is little b?
Yeah.
Okay.
That way, I used the equation we wrote earlier, and then I just plugged in everything. And then for cosine of capital B, I used theta.
For cosine of okay, tell me how you labeled yours. I just need to see that. You labeled your x was what?
My x was b.
Okay.
The 3 was. Oh wait, I see why I can't do it.
See why you can't do it?
Yeah, sure.
Because the side you're trying to solve for and the angle on the other side isn't, they don't correspond. Yes?
Yeah.
Okay. All right, so here's where we are. This is good. A lot of you are going to see something very new for the first time. This is good. I'm trying to solve for x. All right, well, I mean, I could move everything to one side, right? The problem with this is that I still can't factor an x out because now this one doesn't have an x. So I can't pull an x out. There's no greatest common factor. Right?
And the x is over.
How do you mean?
Like, get rid of, move them over mathematically.
Are you saying I can't or
You can,
how do you mean?
like, minus the x squared and then divide by -6x to get the cosine of theta by itself.
But I'm not trying to solve for cosine theta.
I know you're just trying to get the x's separated away from it though.
I'm trying to get Yes, but I want x equals something.
Yeah, exactly.
Not theta equals. What you're suggesting I do is, I think this is what you're suggesting I do, is just go back to this one. I could have taken the x squared to the other side, right, like this, and I could have divided both sides by negative 6x. Right? And then I have cosine theta as this, and I've got everything. I've got basically, if I do this and do arc cosine, then I've solved for theta. Yes?
Yes.
That can be done. That's not what I want, though. I want x in terms of theta. See, because if I solve this for theta, that means you give me x, I tell you the angle where the crankshaft is, the angle of it. I don't want that. I want you to give me the angle of the crankshaft and then tell me, then I'll be able to produce how far the center of the crankshaft is from the bottom of the piston. So that's not quite going to work. All right, let me show you. All right, let's go back. College algebra. This good old quadratic equation, right? The quadratic equation says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And when we did this, the thing that we were always conditioned to believe is that a, b, and c were numbers, weren't they? But I want you to look at it another way, that a, b, and c are just things that don't have x. So look at this first one right here. A is 1, right? B is everything that's not x. Negative 6 cosine theta, and then c is negative 55. Right? That, if I do that and I use this formula, then this will be x is equal to, what's negative b for me here? It's the opposite of negative 6 cosine theta, which would be positive 6 cosine theta. Right? That's negative b plus or minus the square root of b squared. Negative 6 cosine theta squared, which is 36 cosine squared theta, minus 4 times a, 1 times c, which is negative 55.
So plus 270. Oh, no, wait, 220.
Some number, right?
It's a lot.
All over what?
2.
2. Have I solved for x in terms of theta?
Yes.
Yes.
It's not pretty.
It's not pretty. No one said it was going to be pretty. Let's check our answer real quick. Let's see if that works. I'm going to draw this picture again. How long was that arm again? From this point to there was what? 8? So if I'm right here, that would be 8. And then what's the radius of this thing? 3. So in this position, how far away should I be? How far away should I be?
You should be 11, 12.
11, right? It should be 11. What's the angle at that position? 0. Agreed? So let's see if we plug in 0 for theta if we get 11. If we don't, we screwed up. What is cosine of 0? 1. Okay, what's cosine of 0? 1 squared? 1. 36 plus, right, this will be plus 220. So that's what, 256? What's the square root of 256? 15? Is that right? No, 16. So I have this. I have 6 plus or minus square root of 256 all over 2, which is 6 plus or minus 16 over 2. So what's 6 plus 6? 6 plus 16? 22 over 2 is 11. Now the other answer is a scrap answer. It's a crap answer. It's right. It's negative something.
So we're right.
So we look at, well, just because it worked once doesn't mean it's always going to work. What about here? What about at this position right here? Now that's a little more complicated. But that would mean that this distance is what? Right there? Would be 8, right? This is 3. What would that be? You could get Pythagorean because that's 90 degrees, right? So wouldn't that be square root of 64 minus 9, which is root 55? So if theta is pi over 2, we should be at root 55. Shall we even attempt it? Try it. Cosine of pi over 2 is what? 0. Gone. Cosine of pi over 2? Gone. Right? What's this? 220, right? Root 220 over 2 is where we would be. I know I'm moving kind of quick through this. Root 220 over 2. And I believe we can pull something out of that root 220.
Divide by 2.
Divide by 2. So if I pull a 2 out, what is that? 110? I think I can pull another 2 out, can I? If I pull another 2 out, then I could have rewritten it as 4 times 55. And then over 2, and then when I split it apart, root 4 times root 55 over 2, these cancel, I get root 55. It works. So that's probably the first time that a lot of you have seen a quadratic equation used where your A, B, and C were not all numbers. That they actually had variables within them. You can't take pictures though. This is off. No, you may not take pictures. I'm kidding. Go ahead. All right? That's pretty cool, right? I mean, you now have a function. You feed it theta. It's going to feed you how far away that piston is from the center of the crankshaft. All right, so somehow I've eaten up all the time today. Make sure you do your homework for this section. We will start vectors next class. We have a test. I was trying to get into vectors because we have a test coming up. Can you believe that? Which one is that one?
The problem the board was something. That's what I was told last time.
Oh, no, we did it at the end.
Yeah.
You'd walked out and then
I had
come
to go
back.
there 'cause I had to
Yeah,
do
no,
this.
I'll take it.
Sorry.
Yeah, no, I think you thought it was a take-home, but people had worked on it. But I'll take it. I haven't graded it.
Sorry.
No, it's okay.